Welcome, Hornets. In this portion of our lessons, we're going to be taking a look at some special limits. These are limits of transcendental functions. Now, there are quite a few transcendental functions. You know them as cosine. So, for example, we're talking about the limit as x approaches a value of cosine. The limit as x approaches a value for sine. We have tangent. We have all of our reciprocal functions. So let's do the secant. The limit as x approaches a value for the cosecant. Cotangent, cotangent. Make sure I keep these straight. Then we have the natural log. We call that transcendental, the natural log of x. And we have the exponential growth and decay. Just going to start a new column, and we're looking at the limit as x approaches c of a to the x. Now, in each of these, we're not talking about at an asymptote. So the first thing you have to recognize that x and the value of c that we're approaching has to be on the domain. So that's required. And if c is in the domain, it means it's not an asymptote. You're not looking at a situation where you have a jump, okay? All of these don't have two-sided limits, and we're talking about two-sided limits. So on these transcendental curves within the domain, we can simply plug in our value. This would be the cosine of c, the sine of c, the tangent of c, the secant of c, the cosecant, I'm going to put parentheses around that, of c, the cotangent of c. And for these other two, it's just the natural log of c and a to the c power. So with each of these, once again, they are in the domain. Notice a cannot be 0. The c value can't give me an asymptote. I can't have a 0 for the natural log. It's all very basic. All right, so just be aware for these groups, applying it to these values, you shouldn't have any problem. However, there are still 3 other special roots. And these 3 properties or limits we're going to see at various times over the next year and a half, depending upon those of you who are going to BC or not. And the first one says that the limit as x approaches 0 for the sine of x over x is 1. Now, these are like our convention that we were talking about, 1 over x equals 0 for the limit as x approaches infinity. This is a convention. Now, the reason for this is pretty obvious, and it requires us to use what's called the Squeeze Theorem, and that's not obvious. So if you're looking at a graph, this is just going to go boop, 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 and approach, and we're not going to be able to see it very clearly. However, if we use the Squeeze Theorem, and I'm going to be showing that to you in the next video, you will see it. I'm not going to do any of these others with the Squeeze Theorem, just the first one so that you can see how it works. But I want you to know that there are still 2 others. This one is 1 minus cosine of x over x is equal to 0 for the limit as x approaches 0. The third you might have seen before. This right here defines e. So we're approaching 0, and we have 1 plus x to the 1 over x, and we get e. Now, there is one other option, okay? I'm going to show it to you. It is also e, and you're going to learn about it in BC. And the only way to work with it is to work with L'Hopital and L'Hopital's rule, which, as I've told you, you haven't learned yet, and you can't get immediately. This one would be the limit as x approaches infinity for 1 plus 1 over x to the x power. This is also e. So please be aware, we have two situations that we'll work with. These are both found in Calculus BC. So please be aware, you rarely see them in this class. However, every once in a while, I do show you the exact formula here, and I ask, what is it? And my expectation would be that you would call it E. Now, that means that I can manipulate this. After all, we have our power rule that says if I have 2 over x as my exponent, I can factor the 2 out, find E, and then multiply by the square. So we got a lot of things that are happening here, all of which you're probably not going to see until next year. And if I do put it in, I'm going to go over it again with you. Now, why? Why do these work? That's the next video, and we'll be talking about it shortly. Please do the next couple of problems, which are just the basic transcendental functions. They should not be difficult, and then we'll see the squeeze theorem. Thank you very much. Goodbye, Hornet.